not going there. Okay, so I'm going to write that up top. 3.7. I can ... You got to fill that out. Okay, whether you put it on your journal or whatever. I just want you to know that this is 3.7. So we learned how to classify quadrilaterals, and we learned that we can classify quadrilaterals by just focusing primarily on their diagonals, right? We just focus on their diagonals. So the first thing I'm going to do is I'm going to label this parallelogram, and I'm going to call it parallelogram A, B, C, D. Now you need to label yours the same way that I do. Label it the same way that I do, so that way our diagonals are the same. Our diagonals match up. Okay. So our first diagonal is diagonal AC. I'm going to draw that in. And then I'm going to draw in diagonal BD. So if we want to prove that a quadrilateral is a parallelogram, what method did we use? Do you guys remember? Well, we used the midpoints. So we're going to show that the midpoint of AC equals the midpoint of BD. And we're not going to do it here. Whoa, it says my computer is dying. That's crazy. We're not going to do it right now. We're going to do it on the inside, but I do want you to write that as a hint. I want you to write that down as a hint. Okay, so that's to prove that our quadrilateral is a parallelogram. Okay. Midpoint of AC equals the midpoint of BD, meaning those spots are the same. The next one that we're going to do is the rectangle. So our rectangle, I labeled this point G, H, J, and K. And yes, I know I skipped I, but I skipped I because sometimes it looks like a 1 when I write it, and I didn't want it to be confusing. So I'm going to draw my diagonals in there. I have diagonal HK, and I have diagonal JG or GJ. So what method did we use for diagonals? How did we show that the diagonals, like what did we do for a rectangle? We showed that the diagonals are what? Say again? I can't hear you. Nope, that's for a rhombus. The diagonals are congruent. So we have to show that, we're going to use the distance formula. We're going to use the distance formula, and we're going to show that the distance of GJ is equal to the distance of HK. That's how we do that. The distance of GJ is equal to the distance of HK. And then we had our rhombus. So our rhombus, I labeled this one WXYZ. I started over here and I called it W, X, Y, and Z. And I needed to show the diagonals. So I have WY and XZ. And Ken told us that we show that these are perpendicular. Ken, what method do I use to show that things are perpendicular to each other? Anybody know? Anybody remember? I use slopes. I use the slope, right? So I need to show that the slope of segment XZ is I'm going to put is perpendicular. I'm going to use that symbol, perpendicular to the slope of WY. And then I'm going to write a little note that says they have to be the opposite reciprocal. Opposite reciprocal. Do you guys remember that? Opposite reciprocal. And then our last shape was a square. So all I did for my square was label my vertices. All I did for my square was label my vertices, and I called it MNOP, square MNOP. And I said what? MNOP is a square if what? What do we do to prove that we have a square? First, it is a what? Yep, first it's a parallelogram. And what? Yep, a rectangle. And what else? A rhombus. If it is not a parallelogram, then it's not any of those, right? It has to be a parallelogram first. But if it's a parallelogram and a rectangle and a rhombus, then it's a square. And that's the method that we used. So when you're ready, flip it over. We're going to talk about the inside. Who still needs that part up front? Who's still working on that? Okay. So to prove a parallelogram, we show that the diagonal bisect each other using, what did I say we use? What did we say on the front? Midpoint. And here's why I wrote in my formula. Midpoint. X sub 1 plus X sub 2 over 2, comma, Y sub 1 plus Y sub 2 over 2. And this is an ordered pair. This is an ordered pair. So you have to make sure it's in parentheses. Okay. Prove it's a rectangle. We show the diagonals are congruent using what? Distance. And then I wrote the distance formula. Distance, and I used the distance formula. So let's see. We're using distance. Formula. And that is D equals parenthesis X sub 2 minus X sub 1 squared, the quantity squared, sorry, plus Y sub 2 minus Y sub 1, the quantity squared. So that's our distance formula. If we wanted to prove that we have a rhombus, we have to show the diagonals are perpendicular, and that's using the slope. That's the slope. And if I want to find the slope, I say that M equals Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. And I wrote myself a note. Perpendicular means that they're opposite reciprocal. Perpendicular slope means opposite reciprocal. And then if I want to prove that I have a square, to prove that I have a square, I have to show that it is a what? Rattle them off. Parallelogram. A rectangle. And a rhombus. Okay. All right. So once you're done with that, flip it over or open it up all the way. We're going to look at the next page. So we are going to plot the points to this parallelogram. And then we're going to, to this quadrilateral, sorry. And we're going to prove that it's some specific type of parallelogram, right? So the first thing that we're going to do is plot the ordered pairs. We're going to plot the ordered pairs. Is everybody good to go to that next page? Okay. So let's start plotting our points. Point A, -3, +3. Point B, 3, 5. Point C, 5, -1. And point D, -1, -3. So after I plot my ordered pairs, I connect my points with segments. So what do you think? Do you think it could be a parallelogram? Yeah, definitely. What do you think it kind of looks like? A rectangle? Okay, let's see what we get. Someone said square. Okay, let's see if it fits all of the classifications. So the first thing that we have to do is show that it's a parallelogram. So parallelogram, meaning midpoint of the diagonals. That's what I'm going to use, the midpoint of the diagonals. So my diagonals, I need to find the midpoint of diagonal AC, and I need to find the midpoint of diagonal BD. Those are the two midpoints that I'm finding. So midpoints, I'm going to add up the x coordinates. I'm adding up the x coordinates of A and C. That looks like -3 + 5 over 2, and the y coordinates, 3 plus a -1. Plus a negative is the same thing as minus. So this is the midpoint for AC. What is -3 + 5? And 2 over 2 is? Okay. What is 3 minus 1? 2. And 2 over 2 is? Okay. Let's look at the midpoint of BD. So I'm going to add the x coordinates of B and D. That is 3 plus a -1. So 3 minus 1 divided by 2. And the y coordinates of B and D, 5 minus 3 over 2. So let's see. 3 minus 1 is 2. And 2 over 2 is 1. And 5 minus 3 is 2. And 2 over 2 is 1. Emmanuel, I need you to pick your head up and engage. Okay. So I'm going to stop right here and I'm going to go back up to my quadrilateral and I'm going to draw in the diagonals and make sure that they intersect at one, like they bisect or meet at 1.1. And I need to draw, like have a little straight edge. So I'm going to use my little Post-it notes here. So do they actually meet at the 0.11? Yeah, they do. They actually do meet at that 0.11. I'm going to label this capital M for my midpoint. I'm just going to label that capital M for my midpoint because that's what I use to represent midpoint, right? So that just means that we know that this shape is a what? It's a parallelogram. So I'm going to write that. I'm going to write, I do this like little squiggly bracket thing, and I write parallelogram. We have a parallelogram. Okay. All right. Let's look at the next thing that we have to prove. The next thing that we need to prove is what? We have to prove that it's a rectangle. A rectangle. And we do that with distance of the diagonals. And they have to be equal. The distance of the diagonals have to be equal. So I'm going to use the distance of AC, and I'm going to find the distance of BD. All right, distance of AC. So I'm going to go, like, since it's x2, I'm going to do C minus A, right? So X values 5 minus a negative 3. 5 minus a negative 3 becomes plus the quantity squared. And my Y coordinates, negative 1 minus 3. Negative 1 minus 3, the quantity squared. All right, so 5 plus 3, well, that's just 8 squared. And negative 1 minus 3, well, that's negative 4. Notice I put that in a parenthesis, squared. But what is 8 squared? And what is negative 4, the quantity squared? And 64 plus 16 equals, so I have the square root of 80. I have the square root of 80. So now I'm going to find the distance of segment BD, the distance of BD. So let's see. That is my x coordinates, negative 1 minus 3, negative 1 minus 3, the quantity squared, plus negative 3 minus 5, the quantity squared. Negative 3 minus 5, the quantity squared. So negative 1 minus 3, that's negative 4, quantity squared, plus negative 3 minus 5, well, that's negative 8, the quantity squared. And we know that negative 4 squared is 16, and negative 8 squared is 64, just like the last one, equals the square root of 80. So what does that tell us? Are the diagonals equal? Yeah, so this is a rectangle. So we have a rectangle and a parallelogram. We're doing great. So now what do we show? Yeah, we got to show that it's a rhombus. Okay, so let's do some rhombus. So if I want to show that it's a rhombus, I need to move that out of the way. I want to show that it's a rhombus. I use slope, and they're the opposite reciprocal. Opposite reciprocal. So slope of I should probably write diagonals in here. Slope of the diagonal. And they have to be the opposite reciprocal. God bless you. So let's see how far we get. So slope formula, let's see. So the slope of AC, well, that's y2 minus y1. So negative 1 minus 3 over 5 plus 3. Well, negative 1 minus 3 gives me negative 4, and 5 plus 3 is 8. That reduces to negative 1/2. Let's find the slope of BD. So y coordinates, negative 3 minus 5 over negative 1 minus 3. Well, negative 3 minus 5 is negative 8. And negative 1 minus 3 is a negative divided by a negative is a, and 8 divided by 4 is 2. Remember, this is the same thing as 2 over 1. So are these two numbers opposite reciprocals of each other? Yeah. The opposite of a negative is a positive, and the reciprocal of 1/2 is 2 over 1, or the reciprocal of 2 over 1 is 1/2. So they are opposite reciprocals. So I'm going to draw a little arrow, and I'm going to write recip, because I want you to remember that. Opposite reciprocal. That's so important. Whoops, sorry. So this is a rhombus. So we now have a rhombus. Check. So if this parallelogram is if this quadrilateral is a parallelogram, and a rhombus and a rectangle, what can we say about it? Yeah, we're going to say that A, B, C, D is a square because it is a parallelogram a rectangle and a rhombus. Okay. And that is classifying